Good morning, ladies and gentlemen, and welcome to this session on tools to foster climate-resilient urban sanitation. My name is Sanya Lutalo, and I'm a senior water supply and sanitation specialist with the World Bank. I'll be co-hosting this session with my colleague, Nishta Mehta, who is also a senior water and sanitation specialist with the World Bank. The global challenge of achieving universal access to sanitation is enormous, with almost 6 out of 10 people lacking access to safely managed sanitation. And it is exacerbated by the increasing impacts of climate change. We are seeing sanitation systems increasingly impacted by climate-induced disruptions such as floods, droughts, rising sea levels, and extreme temperatures, which amplify impacts on people, on the planet, and on economies. We also know that urban sanitation systems, both sewered and non-sewered, contribute significantly to greenhouse gas emissions across the sanitation service chain. Ensuring climate-resilient sanitation in the face of these challenges is about designing and building systems and interventions that are robust enough to withstand or recover from climate-related shocks and stresses, while also ensuring that fecal matter is safely contained throughout the sanitation service chain and does not contaminate the environment, cause risk to public health, or emit excessive greenhouse gas emissions. Yet many governments, planners, and service providers have yet to fully integrate climate risk and resilience into their long-term sanitation strategies and planning. And so we see that the lack of robust data and evidence is one of the key reasons that there is limited integration of climate change in many sanitation policies and vice versa. For example, sanitation is mentioned in only 5% of NDCs. That was in 2020, and it hasn't improved that significantly even now. It currently receives very small amounts of climate financing. In 2020, again, we saw the climate finance for sanitation was less than 1%. There is a growing understanding, therefore, in the sector that countries need conceptual frameworks and tools to adapt to climate change and build resilience. So a variety of tools and methodologies have been developed by the World Bank and others, academia and various institutions, to evaluate the potential impacts of climate change and to plan appropriate responses to enhance climate adaptation and mitigation efforts and to build resilience in the sanitation sector. This is a very broad and fast-moving area of research and practice and innovation. We would need a day to fully explore the range of available and developing tools. However, in today's session, we'll explore just a few innovative tools and approaches that have been recently developed within the World Bank and externally. Today, we will partner with the University of Technology, Sydney, to examine the urban sanitation and GHG interface, climate interface, by exploring a few tools and resources that help inform the design of climate-resilient sanitation systems, how these approaches are being operationalized in practice in a few cases, and we'll discuss a few pertinent issues relating to climate-resilient policies, actions, and planning. I'll now hand over to my colleague, Nishta Mehta, to introduce the speakers and to moderate this session. Over to you, Nishta.
Good morning, everyone. Thank you, Sanyu. Our first speaker is Ruth Kennedy Walker. Ruth is a senior water and sanitation specialist with the World Bank. She is based in Tanzania, and she is going to talk about a very innovative tool that she's developing with her team in Lake Victoria Basin. Over to you, Ruth.
Thanks, Nishta. Let me just wait for the slides to come up, please. Great. Thank you. So yeah, as Nishta mentioned, I am going to talk today about a tool that we recently developed as part of work ongoing on urban sanitation to support the 5 riparian countries around Lake Victoria Basin, which is Kenya, Uganda, Tanzania, Burundi, and Rwanda. Next slide, please, Erica. Thanks. So basically, we had a larger program working with the 5 riparians to really try to look at how the concept of citywide inclusive sanitation, which we renamed lake-wide inclusive sanitation, could be brought to the riparian to help improve the quality and the lack of access around Lake Victoria as a shared resource. And so we started. One thing the project wanted to do was to explore the possibility of accessing climate financing. And so to do that, we really need to understand the greenhouse gas emission profile. And so when we started to explore, we realized there were tools out there. There were some tools even within the bank, but we felt that they were very reliant on the IPCC guidelines, which is found to cover off-site sanitation, so sewerage quite well, but on the aspects of on-site sanitation, they're not thoroughly explored, and actually the data, more of the recent research, especially on on-site sanitation from places like Uganda, is not captured by IPCC. So what we found is the current tools were basically underestimating GHG emissions, especially for those countries where, like the riparians I mentioned, that are highly reliant on on-site sanitation. Next slide, please. So we wanted to develop our own tool. So we partnered with a firm called Climate Focus to develop a tool that would obviously rely on the information from IPCC, but also include other data, more recent data, to get a better estimation of GHG emissions across the sanitation service chain and for both on-site and off-site sewage systems. So we started with the input data. So in some of the locations, some of the towns around Lake Victoria, there was the SFDs were available, which provided data. And then in those that didn't have the SFDs available, we did a rapid assessment. So we actually did a baseline, I suppose, sanitation assessment for 44 settlements to show the current sanitation situation. Next slide, please. Then we developed the model. So as I mentioned, we built on the 2019 IPCC guidelines, but complemented with more up-to-date peer-reviewed literature. And we were trying to see the categories of emissions you can see from the table there across the sanitation chain and for both on-site sanitation and sewage systems, and both from direct or operational. Next slide, please. And this is just to give you, obviously we have a very short amount of time to discuss, but this is a screenshot from the Excel-based tool model, which is based in Python, and shows you across the different pathways and across the sanitation chain, the type of elements that were being looked at to get the GHG profile. Next slide, please. Sorry, back one, thanks. So then the model, we worked to come up with an output interface on the model, which basically, this is obviously a snapshot, but it basically highlights the total emissions across the 44 settlements. It identifies where are the top emitting settlements, which you can see. Then it looks at where across the sanitation service chain is the highest emissions coming from, and is it coming from safely and unsafely managed? And this is obviously the baseline. So this is the current situation. And the idea is to be able to help government counterparts, practitioners, and the World Bank to be able to identify where should they, if greenhouse gas emission reduction is the priority of a project or it's a key element, then where across the sanitation service chain should they be focusing, and maybe even geographical locations. So as I mentioned, so the tool was meant to, when we started out, we wanted to do the baseline scenario and then also go one step further and then even input, I suppose, like potential future interventions and see how that would impact the GHG profile for each city or across the country as a whole. But unfortunately, we ran out of time and funding to do that. So we ended up just doing the baseline scenario for the 44 settlements. But I think overall it was still a successful outcome because we were able to get a better estimate of the greenhouse gas emissions for using the more recent literature for countries where there's more reliance on on-site sanitation than sewage. I think the model allows us to be able to, as new literature emerges, because there's a lot of research going on at the moment on this, the model, those parameters can be inputted and then the model can be updated. I think it's, as I said, it's a good model to look at the main intervention stages across the sanitation chain. And we're actually, this was the first development of the model, and we're now looking to utilize the model in a new project in Indonesia. I'll talk a little bit more about that later if I have an opportunity. And we will do the second phase. So the baseline, and then in Indonesia, we'll actually look at how proposed interventions would change the greenhouse gas emission profile, and that will impact the project design and what is actually being constructed, or the service delivery model that is going to be used across the sanitation service chain. I think also, as so the Indonesia work is very exciting, and I think Sean may talk to this later, but I think this is the way we want to go within the bank. We want to be more climate informed within our operations. I think this model and the way we're able to include more recent literature coming out as it emerges will be good for it, will help us to really get as close as we possibly can to realistic data. And then obviously in the Indonesia case study or in future case studies, I think the next step would then be helping the client to monitor the actual reduction in GHGs, which is obviously where that's something that needs to be done, sorry, to ensure that the financing, that's what the climate financing bodies are looking for, that you can actually accurately monitor. Just while we're on this, so part of this assignment was also looking at the climate financing landscape from both mitigation and adaptation. So that was also a separate part. So the model, while we didn't go that one step further, we were able to work with the governments to look at, okay, what might be viable options for climate financing if the greenhouse gas emissions, we were able to show that there could be a large reduction. But I think that work in itself was quite useful to show what's possible and what's not, and what the governments would need to do in terms of being accredited, etc. Anyway, I think my time is up, so let me stop there. Thank you so much.
Thank you, Ruth. I think that the next presenter is Jeremy Koritz. Jeremy is a water and sanitation researcher with the University of Technology, Sydney. His primary areas of expertise include interdisciplinary and applied research on the sustainability of rural wash and urban sanitation. He has a special interest in climate change impacts on wash, and we should hear more about that today. Over to you, Jeremy.
Thanks, Nishta. So before I start my presentation, I want to put a question out there. When you think of the toilets that you see in your work, whether they're in rural areas or urban areas, what proportion of them do you think are climate resilient? Is it 50%, 20%, or maybe not any of them are resilient? You can keep that to yourself, but I was asking this because one thing I'd like to get across in this presentation is to get us thinking about what would it take to make a sanitation technology resilient. Next slide, please. So my colleagues and I at the University of Technology, Sydney, have been thinking about this, and we developed something called the Climate First tool, which is a 5-step process to help sanitation technology developers think through how to make a sanitation technology more resilient. And before I go any further, I want to highlight that climate resilient sanitation is about much more than technology. It's about institutional arrangements, financing, regulatory frameworks, lots of things. We're not going to just engineer a toilet that will solve for climate change. But technology is an important part of the equation, and that's what we're zooming in on here in this tool. So the tool itself, it's an Excel-based process that helps the user think through how different climate-related hazards might affect a particular sanitation technology. and how we can reduce the risk of those hazards through improved technology design. So the reason why we might want to do that is, of course, as we know, climate change is heightening the climate risks that technologies are exposed to, and we want toilets to perform better in an era of climate change. The tool can also be helpful in comparing different types of sanitation technologies if you were to do an assessment of two different technologies and then compare them side by side. So it's for anyone that's involved in the design of sanitation technologies or their implementation. So that might be a developer that's coming up with designs or an implementer that's making choices about which ones to implement. And finally, when I say sanitation technologies, I'm referring to non-sewered, on-site, decentralized containment and treatment technologies. So not referring to sewer networks and wastewater treatment facilities. Next slide, please. So the first step of the tool is to decide what is the sanitation technology that you're assessing. So in this example, these are some photos from Dewats in Indonesia. And you might say, well, we want to assess the containment unit part of the technology, and we want to, for example, assess the main sewer line here. But we don't want to assess all the household connections because maybe we don't have control over that. And maybe we don't want to assess the superstructure because as a developer, I don't have any control over what the community constructs as a superstructure. So I'm excluding that from my assessment. Next slide, please. The next step then is to decide which hazardous events and trends are relevant for your area. So the Climate First tool supports an assessment of 8 different hazardous events and trends that you see on your screen. And you might choose that you're just concerned with floods or droughts. Or for example, if you're in a landlocked country, you're probably not too worried about high sea levels. So you would just pick the hazardous events and trends that you think are relevant for your technology. Next slide, please. So then the Climate First tool will take the hazardous events and trends that you selected and display a list of hazards that are associated with those. So for example, I've pulled up a list of the hazards that will come up if you select floods and droughts, which are associated with a range of different things like landslides, erosion, force of floodwaters, and so on. And at this stage in the assessment, you would assess the extent to which these hazards would affect the sanitation technology you were assessing if it were exposed to that. And the Climate First tool gives a specific quantitative example of each one of these hazards. And you would say, I would think it would either have a low, medium, or high impact on the technology that I'm looking at. Next slide. So after you've done this sort of assessment of all the specific climate hazards, we then look at the technology itself and consider to what extent does the technology already have resilience design features incorporated that could help offset some of those hazards, or what could you add on to the technology design in order to improve it? So we went through literature and came up with 25 different design features that one could incorporate into a sanitation technology design to make it more resilient. And I don't have time to go through all of them today. I'll just go through a few just to give some examples. So the first one I think is one that people think about often when we think of sanitation resilience, and it's raising, so just lifting up the technology so the important components of the sanitation technology don't get exposed to something like the floodwaters. A second feature is portability. So if you think of container-based sanitation, you could literally pick up the toilet and move it away from the hazard, the flood or rising sea levels or whatever it is. Container-based sanitation also doesn't really have electricity inputs, it doesn't have water inputs. So there's fewer things that could become exposed in the first place. So that's why these design features fall under the avoiding exposure to hazards category. The next example is shapes that distribute pressure. So there's a lot of interesting research out there that shows that structures that have cylindrical or spherical or geodesic shapes are less likely to be damaged during hurricanes, cyclones, and floods. So if we construct sanitation structures to have those shapes instead of cube shapes or square shapes, they're likely to withstand the exposure to certain hazards better. Next design feature is redundancy and diversity, which falls under enabling flexibility. This comes up in resilience literature a lot. So for example, a twin pit latrine has 2 pits. In the event that one of those pits collapsed, say during a flood, at least you still have the second pit. People can still continue using the toilet until the first pit gets repaired. So there's redundancy in the containments. And then finally, I'll skip ahead to the last category, which is about providing benefits beyond sanitation technology resilience. So the design feature of hybridizing refers to technologies that provide a sanitation service, but also provide some other service that helps the community beyond just sanitation. So an example is a biogas toilet. It provides a meets a sanitation need, but also produces biogas, which can be a clean energy source that can help with other aspects of community resilience. So a final point I want to make about these design features is that more is not necessarily better. You don't necessarily want to incorporate all of these 25 design features into a toilet. If you tried, you would come up with a very convoluted and probably very expensive toilet. So it's more about picking which ones would help you deal with the hazards that you assessed in the earlier step. I also want to make a quick point about how I think the future of climate resilient sanitation technologies is going towards standardization and professional production of sanitation products. And I think as we move more to more professional designs of sanitation technologies, we can think about how certain resilience design features might fit into a standard climate resilient design. Finally, on the last step of the process, the Climate First tool will sort of count all of the hazards in which you said had low, moderate, or high impact, and then it'll calculate a score, low impact, moderate, or impact based on the proportion of hazards that you said were low, moderate, or high. And then the user themselves gives the resilience rating of low, high resilience. So they reflect on what they thought about during the hazard assessment, what they thought about during the resilience design feature assessment, and they make a call on whether they think the technology has low, medium, or high resilience to that particular hazardous event or trend. So that's all from me. If you'd like to learn more about the tool, there's a QR code here, or you can go to the link uts.edu.au/climatefirst. We have lots more materials about the tool, a video tutorial on how to use it, and of course, the tool itself is available there for download. Thank you.
Thank you so much, Jeremy. And let me just move on to our next speaker. Sean Nelson is a climate change specialist with the World Bank's Water Global Practice. He's based in DC. He advises on climate-informed project design and climate change mitigation and adaptation issues. And he's been working at the intersection of climate finance and climate change mitigation. So over to you, Sean.
Thank you, Nishta. And thank you to the other presenters and to Celia for hosting us today. I'll be discussing the tools that we've developed within the Water Global Practice, the World Bank, to help inform our WASH projects from a climate resilience standpoint. Next slide. Now, for at least a decade, the Water Global Practice has understood that our clients are highly exposed to climate change shocks across the entire water sector, including when trying to plan for WASH investments and policies, and that they are going to need to have informed analytics and well thought out frameworks for how to approach infrastructure planning, policy development, and so on. And that it's our responsibility as the World Bank to make sure that we can provide them with those tools, methodologies, and frameworks. And we've been developing these, but also refining them over the past decade, based both on our own experiences, but also the ongoing academic and government research that is publicly available. This is to make sure that not only are we going to have to build resilience against climate shocks, but make sure that we are also simultaneously meeting SDG 6. We also want to make sure that our clients aren't basically starting from zero or trying to say, take GCM that is already publicly available and trying to downscale it in a way that the model was not meant to do to stay at the level of a neighborhood where the data might not really be usable or reliable in terms of trying to plan, say, an on-site sanitation system. But instead, we can help them based on building off our own experiences. So I'm going to showcase 3 methodologies and frameworks we have developed within the World Bank and apply the projects for our clients. Could you please go back very quickly? These 3 right now are the Resilience Water Sector Infrastructure Design Brief, the EPIC Response Framework, the Water Security Diagnostic Initiative, and also not listed here is also hydrological stress testing as well. These aren't the only frameworks we have in the World Bank, but are the ones that I'm going to highlight today. Next slide. Now, the Resilient Water Sector Infrastructure Design Brief is a conceptual framework that builds off prior research and frameworks we had developed within the World Bank. Those two were what we call the roadmap and the decision tree framework, which we've highlighted here and are both publicly available, basically guiding our clients through the process of how to conceptualize the impacts of climate change when designing water sector projects and how to approach the issues around, say, uncertainty. It has a 6-step process that is mostly focused on water supply and sanitation, but the lessons can be also applied to other sectors as well. First is identifying the system components and conducting high-level hazard screening. Second is understanding the role of components in the system and understanding the consequences of failure. The third is identifying and assessing component failure modes. The fourth is evaluating the hazard levels and comparing with the component failure modes. The fifth is identifying component risk mitigation options. And the sixth is evaluating and selecting component risk mitigation measures. So I would say in general, you really want to think through not what is the specific risk that comes from a particular, say, GCM, but what are the possible sources of failure if you're constructing, say, wash infrastructure in a particular area due to climate shocks, and what can you do to mitigate those risks? Next slide. And so here we have the 6 steps highlighted and how they correspond with the 3 phases of the roadmap to show that we are iterating on our previous work and making it more refined over time. Next slide. Another framework we developed in recent years is the EPIC response framework. And this is looking at floods and droughts. I'll actually combine floods and droughts into the one word there where you can understand how closely linked they are. We often talk about them as being 2 sides of the same coin, not as independent events, but 2 different types of shocks that clients will need to deal with. I can say from my own experience that going to field in places like, say, the dry corridor of Honduras, when planning for projects there, that you can have literally the same neighborhood that will be flooded potentially due to climate change in one part of the year and dealing with a major drought just a few months later within the same calendar year. This provides a comprehensive framework to help a national government lead a whole of society effort to help mitigate these risks and to carry out contingency planning and understand how that should be integrated into the wider planning context when a government is deciding to invest in infrastructure and creating investment programs. Next slide. So you can see we have the breakdown of how we are conceptualizing and communicating EPIC response framework. The first is making sure that we're enabling the clients through, say, national frameworks, a whole society approach, and providing specifically hydromet services. The second is planning. So this is flood and drought risk mitigation and contingency planning. The third is the actual investment in both improved watershed management and more broadly, improved WRM. The last is control here, and that is making sure that we are approaching the water allocation and groundwater management, as well as the floodplain management from an informed standpoint that takes into account the climate change risks that are going to be potentially affecting a location. Next slide. Another is the Water Security Diagnostic Initiative. Now, through this initiative, we provide client countries with technical expertise, instruments, and financial resources to help actually carry out the diagnostic, make it publicly available, and make sure that the country is taking a broad and overall approach and understanding to how climate change will affect the water sector more broadly. Now, you might be thinking, how does this affect sanitation? Well, as we were discussing for EPIC response framework, you definitely do need to take into account the effects of flood and droughts on the water sector broadly, but also for sanitation. Say if you have a wastewater collection system that relies on regular water flows, if there's a drought, and that system is going to dry up, it's not going to operate well, or if there's a flood, it can overwhelm the system and help to contaminate the rest of the local area. We have provided several of these reports publicly. I believe we have roughly 24 that are available. On the next slide, we will showcase, we have the overall framework here looking at people, the environment, and economy, and how it makes sure that we are providing the infrastructure, the improved infrastructure and the improved institutions to lead to a better water endowment and better water management. On the next slide, we have some examples of recent diagnoses we've carried out for Peru, Moldova, and Vietnam. These are just the ones I'm showcasing here. There are more available as well. Next slide. So the last one I'll discuss here today is hydrological stress testing. Now, this methodology is still under development, but we have been working with clients to pilot it in practice. Now, it involves generating climate trajectories, evaluating performance under each potential future, and then mapping the sensitivity of different changes to that future. So basically, we wanted to make sure that we had an ability to give clients multiple options, a wider range of views of what could potentially happen under climate change, that they're not being very hyper-specific in terms of how they are building infrastructure with regard to climate change, but instead understanding there's a range of potential outcomes that might happen because of climate in a particular region, that we want to be able to provide this information much more quickly than existing methodologies are able to do so, and that we can do this in a cost-effective way that makes sure that you are well informed on how to actually approach your investments and your policies. So that's it for me. I'm reaching the end of my time, and thank you.
Thank you, Sean. So I would like to invite Jose Casti to give us a few remarks as a discussant for this session. Jose works as a senior climate action advisor to Sanitation and Water for All, providing support in policy and strategy, as well as country engagement on climate action, water supply, and sanitation. Previously, Jose has also worked for UNICEF and the Ministry of Water Resources and Environment in Spain. Over to you, Jose.
Thank you. Thank you very much, Nisa. Ladies and gentlemen and colleagues, thank you. First of all, thanks for this opportunity to provide some reflections on this critical topic of climate resilient urban sanitation. I think the presentations that we have just seen have surely highlighted the significant role of urban sanitation, the role that urban sanitation plays, not only in public health, but also for environmental protection, and also in the broader context of climate change adaptation and mitigation. From the presentations, we can draw a few essential conclusions. I think first, Ruth's analysis on the greenhouse gases emissions from sanitation systems in the Lake Victoria Basin bring to light the often overlooked contribution of non-sewer sanitation systems to greenhouse gases emissions. I think, Son, you have started the session by referring to a very low percentage of sanitation nationally determined contributions presence, right? Like we are not happy with how sanitation currently is included into climate policy. So Ruth has also showed to us how the baseline greenhouse gases emissions tool that she has introduced offers a practical methodology for identifying and mitigating emissions across the entire sanitation service chain, which is vital for shaping more sustainable urban environments. Second, the climate first five-step framework that has been presented by Jeremy has provided a comprehensive toolkit for assessing and enhancing the resilience of sanitation technologies. Jeremy has emphasized that technologies is an important piece, but not the only one. And we also need to work with enabling environments and policy. But Jeremy has made emphasis on the need to consider diverse climate hazards as appropriate, ranging from floods and droughts when designing sanitation solutions. And this is a reminder that our approach to urban sanitation must be holistic and adaptable. Then finally, Sean's discussion on the need for resilient water sector infrastructure has underscored the importance of designing sanitation systems that can withstand climate shocks. The approaches that Sean has presented, including the last bit on stress testing of infrastructure components, I believe is crucial for ensuring that urban sanitation systems are not just functional, but they are also resilient in the face of increasingly unpredictable climate events. So after this, I would like to share some remarks and some reflections or recommendations from my side. So as we move forward, I believe it's crucial that all the stakeholders in urban sanitation not only adopt these innovative tools, but also we collectively advocate for the integration of these tools when it comes to planning processes, specifically for climate, both for climate and sanitation policies. So I'd like to discuss about integrative planning, cross-sector collaboration, and also policy integration. In regards to integrative planning, urban sanitation should be treated as a central element of climate resilient urban planning. This means that embedding tools like the ones we've seen today, these tools need to be integrated into citywide climate adaptation strategies. In relation to cross-sector collaboration and given the fact that water management intersects with food security, also with energy production and ecosystems health, I believe it is essential to foster collaboration across all these sectors. And by doing so, we can ensure that urban sanitation systems, again, they are not just resilient themselves, but they also contribute positively to broader climate resilience goals. And then thirdly, on policy integration, I think that the lessons from the presentations today should inform national and local policies. By integrating climate resilient sanitation tools into the processes to develop and formulate national adaptation plans and revisit and enhance nationally determined contributions, this can significantly enhance the options for sanitation to feature more strongly, again, both into climate policy and then also into sanitation policy. So in conclusion, the tools and strategies discussed today provide us with a robust foundation for making urban sanitation systems not just sustainable, but resilient in the face of a changing climate. So let us take these insights forward and work in a collaborative way to implement all these tools and scale them up. Back to you, Richard.
Thank you so much, Jose. I think this was the perfect summary of everything that we heard today. Colleagues, I would also just like to say, please post your questions in the chat. Our presenters are directly engaging with the chat and answering your questions. So let's keep that discussion going. And with that, I want to just segue directly into our panel discussion. Both to save time and also to just continue the really interesting discussions that we've been having. Some of the tools that you've heard today are pretty much hot off the press. They're coming up now. They're being developed now as we speak. So I think this is a really good opportunity for us to learn more about them and see how they apply to the work that we're all doing in our various organizations and institutions. So going into the panel discussion, Ruth, you were our first presenter, and I'll take the first question to you as well. Can you tell us a little bit more about how can policymakers use the tool that you're developing to really mainstream climate resilient sanitation into their policies and programs? What do you see as the next steps on that?
Great, thanks, Nishta. Thanks for the question. So I think the tool really is providing the data, right? So it's really being able to, especially for those governments, like I said, we found that the tools that were currently available were not really taking into consideration what was really happening with on-site sanitation, which many countries around the world, we see large proportions of the population reliant on on-site sanitation. So the tool was really to bring in most recent research so that then governments are able, the policymakers then have the real situation in terms of what is the greenhouse gas emission profile for the situation that they're facing. So I think that's the first thing. So providing them with more accurate data on their current situation and what it means. And then allow, again, I think another nice thing about the tool is the way it splits, the safely managed and unsafely managed, because it, again, obviously unsafely managed has huge implications on public health and environment. They're the key focuses, but actually also from a climate perspective, we're seeing that actually large amounts of emissions are actually coming from unsafely. So it then also advocates further to policymakers that they need to focus on moving people who currently maybe have unsafely managed to safely managed across the service chain, not just at containment, but all the way through to safe disposal and reuse. And so I think it then, that can then feed into relevant policies and programs. So obviously the NDC, the nationally determined contributions being one, having more accurate data of the current situation. And then, if sanitation, I think we're seeing that sanitation is actually, because of the previous issues with modeling, we see that the greenhouse gas emissions from sanitation could actually be much higher than previously thought. And so actually making interventions in the sanitation sector could help on the government's nationally determined contributions. And so I think the tool overall can really help policymakers, understand better what's really happening with the most up-to-date data. And then obviously on the planning front, right? So, okay, where do we need to focus our time, maybe geographically, but also, at which part of the service chain, and also this thing around between unsafely and safely managed, where we have populations that currently have access through unsafe means. Let me stop there, Nishta, I think. Thanks.
Thanks, Ruth. I think this is really interesting, and I'm seeing a lot of questions in the chat that talk about operationalization of this tool, which was something that I would love to hear more about as well. But I also I'm also cognizant of the time, so I'm going to move on to Jeremy. But if I have time, I'm going to come back and ask you about the application of this tool, where you're introducing it and how that's going. So, Jeremy, I think your presentation and what Ruth talked about, there are a lot of parallels in the work that you guys are leading. But I also want to ask you about the opportunities to standardize climate resilient sanitation technologies. How could this be done exactly? Have you done this before? I would love to hear more about that. Thanks.
Sure, thanks, Nishta. And no, I haven't personally standardized any climate resilient sanitation technologies yet, but I have ideas about how it could be done. So many of you are probably aware that there's been recent advances in developing ISO standards for non-sewage sanitation systems. And having these standards is really good for three reasons. One is it sort of provides something of a benchmark for safety and reliability, so that we can say if you design a sanitation system like this, we can be confident that it'll protect public health and it will perform well. And that's helpful for regulators as well. Number two, it provides guidance for technology developers if there's standards that they need to meet. So it gives them sort of guidance on what they should be designing for, and sanitation stakeholders kind of know what we should be working towards. And then number three is it helps manufacturers of sanitation technologies gain access to markets. So if they can demonstrate that their sanitation technology meets the standards and is perhaps certified as meeting standards, they can gain the trust of regulators and gain the trust of the public. So I think standardization of climate resilient sanitation technologies would feed into that. How can we reflect climate resilience in those standards? That doesn't necessarily mean ISO standards, which are held to a very high degree of rigor. It could be national standards or even some sort of subnational standards. And we can just think about ways and what are some standard ways in which you could test a sanitation technology to show that it will perform well under flooding, or are there certain design features that we can say, well, these should be incorporated in every sanitation technology so it won't fall over as soon as there's a big storm. So next is that I get excited about the possibility of locally manufacturing prefabricated sanitation technologies. And I think if you had standards and you say, well, this is how the design should look like, I think it's realistic in a lot of low and middle income countries to actually have a central manufacturing process. And I think that's a good idea because the reason a lot of the toilets we work with don't work very well, even in the best of conditions, let alone very wet and very dry conditions, is because they're constructed informally, they're constructed by the households or untrained masons, or the government might hire someone to do it, but then that person's, there's no incentive for them to follow any real quality assurance processes. But if you had something centrally manufactured, you could say, the government could say, okay, here's the design that we want. It should meet these standards. It's in a central place, so it's easier to monitor and regulate. Those designs could incorporate climate resilience design features. And if you had a really good process, then you can almost set up an assembly line like process and roll out these technologies and monitor, regulate them, certify them, and then take them from the factory and then drop them in wherever they're to be installed. And I think that's another entry point for climate resilience standardization, is then you work that into the design. The last point I want to make is I think there's an opportunity for the international community to support something like that through thinking through, the designs of technologies that could be manufactured locally. So I'm thinking of something like, a lot of you are probably aware of the Bill and Melinda Gates Foundation Reinvent the Toilet Challenge, where they come up with toilets that recycle water and they recycle nutrients and they recycle energy and they do lots of things. But I'm thinking of something more like, what's a challenge that can someone design a toilet, or excuse me, a sanitation technology, a containment treatment, non-sewered sanitation technology that's can be manufactured at scale in a low and middle income country context. It creates a product that's affordable for people. It can be easily emptied. You can pick it up from the factory and easily install it at a household or an institution. Ideally, it would have a low carbon footprint in the manufacturing process, and it incorporates those standards that we want, which might include climate resilience standards. Come up with the design and then pick the winning one, and then see, the government could incentivize the private sector to get involved in manufacturing that design. So that's just an idea. As I said during my presentation, I think getting to a stage of climate resilient sanitation technologies isn't going to happen in the current way things currently work with its informal constructions and installations, but having a regulated, centralized manufacturing process shows some promise. In some urban areas, rural areas, it's probably less realistic, but I think there's definitely places like Indonesia or cities in South Asia that have that capability. Thanks, I'll stop there.
Thank you, Jeremy. I think that was really interesting, and I see a lot of questions coming up in chat based on, your remarks just now. It'd be great if you could just take a look. I don't think we'll have enough time to just come to those questions centrally, but if you could take a look, I think there's some really, really interesting questions coming in there. Sean, I'd like to come back to you. We've heard from both Ruth and Jeremy, and from my own experiences as well. One of the major challenges of designing climate resilient infrastructure is decision-making under uncertainty. So as an advisor to World Bank project teams, and based on your knowledge, what information gaps on climate risk do you see in designing sanitation projects, and how do you think these gaps can be best filled?
Thank you, Nisha. Well, I would say that, first of all, it's going to be important to know that you will never have perfect information. That's especially with climate change, that the perfect information issue is always going to be there even before climate change was an issue, and that's already definitely has exacerbated it. But I would say we do have the data sets analytics to carry out things like, say, stress testing, and can give clients a greater understanding of the most likely outcomes of what they're going to be facing on the ground with regard to climate change. So I think one of the most important lessons with regard to uncertainty that we've tried to impart to our clients is making sure they aren't thinking of, well, we need to over design everything specifically to prevent failure of this particular type of flood. But instead, if we have a range of particular risks that we are facing, what can we do to meet the challenges faced by the range of risks? We're never going to know until a flood happens exactly how big it is, but we can deal with the ones that have a good chance of happening within, say, the next 20 years when designing a project. We have the analytics and the models to be able to see under, say, different GCMs and under different assumptions what those outcomes will be and how to design around it. So I would say that as long as you can have the conceptual step of understanding you're never fully going to have perfect information, and we are having improved data from, say, GCMs, from work that we're doing within the bank, from academia, we can make sure that we are giving people a range of data points and a range of options of how to best approach resilience planning within WASH and the broader water sector.
Thank you, Sean. I think this is really, really interesting. And I think also very good segue, because we went in our presentations, we went from these tools to a project-specific approach and then a more broader approach with Jose, and we followed a similar pattern with our panels. So Jose, coming to you, our session today has had a very practical approach showcasing tools that foster climate resilient urban sanitation in different contexts. In the role that you're playing to integrate water supply and sanitation into global climate negotiations and agreements, can you tell us how the conversation is going today, and what can we do to help influence and support these global processes?
Thanks very much, Nista. Indeed, what we are discussing today is pretty relevant, and although it may sound a little bit far away from us, like what we're discussing is well linked to where the climate negotiations are right now. So broadly, the climate negotiations follow three key tracks: one on adaptation, another one on mitigation, and another one on financing. This is a broad summary, right? In terms of the adaptation and resilience negotiations track, we are in a very good place. Last year, we managed, and this is a big step forward. We managed to have climate resilient sanitation spelled out in COP28 decision. Not only that, but climate resilient sanitation now is a centerpiece of the new global climate resilience framework that brings targets and is calling for climate resilient sanitation services towards 2030. So in a few years from now. From Sanitation and Water for All, we appreciate very much this discussion, and we are willing to play this role of bridging these very tangible and practical discussions with the climate negotiations. Now we have climate resilient sanitation featuring so highly on the global agenda, our credibility is on stake. So we need to demonstrate to the world first that we have a common definition and understanding of what a climate resilient sanitation service is. And these tools that we're seeing today are helping us in this direction. And we need to also bring down this global framework into national and local policies and strategies. And I think the tools that we've been discussing today are really going in that direction. In relation to the mitigation track, the world has conducted what is called the first global stocktake, meaning that the priorities that countries have put forward in terms of reducing greenhouse gases emissions after this global stocktake, we have realized and we know that we are not on track to the Climate Paris Agreement. So we need to raise the ambition. And today it's been clear that through sanitation, we can further reduce greenhouse gases emissions. So our sector, urban sanitation, is a real opportunity that we need to put in front of climate negotiators as an opportunity to further enhance national contributions to reduce greenhouse gases emissions. It's a real opportunity. Countries are in the process and have been requested by 2025 to revise and enhance the ambition of their nationally determined contributions. So let's pitch for sanitation. And then finally, just briefly, the third negotiation track, important, and we are making strong references today, it's in terms of the climate financing. This year at COP29, we're going to see what is the new agreement in terms of global climate finance. Developed countries will commit. We have always heard about this 100 billion commitment that was agreed in the Paris Agreement. So we are going to revisit this year at COP29 this agreement. So we will know what is the new commitment. And then again, having these tools and practical approaches to sanitation, I think it's important to build our credibility and to first inform climate and sanitation policy. It's going to give us and put us in the right position to then benefit from climate financing. I will leave it there, Ms.
Thank you, Jose, and thank you really to all our wonderful panelists for this discussion. I think there are so many questions coming in chat, which just shows how interesting this topic is for everyone and how much people want to engage on this. Unfortunately, we're running out of time, so I will hand it back to Sanyu for closing remarks and for closing out the session. Thanks, Sanyu.
Thank you, Nishta. As we draw this enlightening session to a close, I would just like to thank our speakers and participants for these excellent contributions to this important ongoing conversation. We have traversed a landscape of knowledge and innovation, exploring several practical approaches in which we can enhance adaptation in urban sanitation systems to respond to the realities of a changing climate, while at the same time mitigating GHG emissions along the sanitation service chain. We have seen that promoting climate resilient sanitation planning is not just about technology. It needs to be complemented by supporting enabling environments, including the policies, the institutional and regulatory frameworks, as well as the financing aspects. And resources need to be allocated for testing and application of the innovations in order to promote climate resilience, as well as to influence global climate policy negotiations and agreements. So there is an opportunity to anchor, there is also an opportunity to anchor climate resilient sanitation planning into the broader resilience approach, working across urban sectors, taking a broader citywide inclusive sanitation approach. So we need to look beyond just sanitation, but looking at the impact of sanitation on the broader, urban resilience aspects. So moving forward, we will continue to take an iterative approach. There's a lot to learn from one another, building on the knowledge that has been gained from these and other related initiatives on the topic of climate resilient sanitation. And we need to work collaboratively across institutions, across the sector, and cross-sectorally to respond to the current challenges. At the World Bank, we're currently finalizing an analytical work, complementing all the tools that we've already talked about, on the imperative for climate resilient sanitation, where we are assessing linkages between urban sanitation and climate change, with a focus on low and middle income countries. And we are aiming to make recommendations on the policies, the institutional arrangements, regulations, funding mechanisms, and incentives needed to promote climate resilient urban sanitation. So this is ongoing work that we expect to complete by the end of the calendar year. As we conclude this very interesting session, let us carry forward the insights and the inspirations from today's discussions. Let us pledge to continue the collaboration, to share our knowledge and experiences, and to support one another in this critical mission to ensure that our sanitation systems are not only climate smart, but also a testament to our collective resolve to build a more resilient world. Thank you very much for your participation.